Doing it. Buttons are clicked. We're live. This is Boink Radio episode 108. I caught Delta in his PJs. That's how quick we launched this. Show off your PJs. Let's see it. Come on.
Okay, yeah, I got the Athena
Woo!
tank top. Yeah, look at that.
You're not seeing incorrectly. And no, he did not get shot. And no, it's not a logo. Why is it blurring out? I guess it is. It's kind of the logo of Athena. That there is a map of the internet and a t-shirt. How cool is that? And welcome everyone to the episode where we'll be talking about the Boink Workshop Day 2. I heard there were some firecracker presentations. There's someone doing something with AI that sounds really cool. That was the big one I heard about. So we'll get right to that. First, as always, dude's going to drink some liquids.
Actually, I think I picked out something that's probably the healthiest drink I've brought. That's a soft drink. It's called Sun Exotic.
When is the sun not exotic when you think about it?
I don't know. But this is a pineapple and coconut sparkling drink. And apparently it's really great value, 59p only. I think it's, it's a UK or European drink by the sounds of it. They're working in pence. So the reason why this is the most, probably the most healthiest drink I've had on the radio is because it only contains 4 grams of sugar.
I don't think you're legally allowed to drink that on the radio unless it's over 60.
Not by tradition. But anyway, it contains 11% real fruit juice, apparently. So we're about to find out whether that's true. Anything interesting in the ingredients? I don't think so. Whatever the hell Gellan gum is. Drink chilled. Any interesting messages on the front?
Shut up and drink your gin.
It's just plain old chilled fruit juice.
Drink. Review. Proceed.
It's very coconutty.
Ooh, coconutty. Best kind of nut.
Actually, it's like
nut or fruit. Googling.
I think it's a fruit.
I'm seeing it with a fruit, which botanically is a drupe, not a nut. You're a drupe. Carry on. Sorry.
Wow, thank you.
You're welcome.
Okay, so the way I describe how this tastes is if you got pineapple juice, like you can get like pineapple punch and stuff like that from the supermarket, and then mix it with the like coconut water that you get from the supermarket as well. If you just mix those two, carbonate it, and you have this drink right here, which costs 59p.
All right, 59 bananas for a drink. Boink news. Let's go. Wait, sorry. Rank it.
Oh, rank
quickly.
It. Yeah.
Rank.
6 out of 10.
6 out of 10. Not great, not bad. Right in the middle. Coming out of World Community Grid's Africa Rainfall Project. Since they've moved to Kremble, they're really leaning into the 3-letter acronyms. So I was like, what's the ARP team? But World Community Grid has put out 3 updates from 3 different projects this month. This one's coming from Africa Rainfall Projects, which is looking for, you heard it here first, the rain in Africa. It's looking for 95. No! Shoot. Sorry. I had something on the stove and I forgot and it just burned. I'm back.
Uh-oh.
All right. They're looking for 95% of the rain that comes from rain. Water in Africa comes from rain. 95% of it. 5% we don't know. But we here at the Boink Radio suspect also rain. All right. So, enough of this nonsense. As of December 2022, the ARP team has paused releasing new work units until they resolve the capacity limitations of the storage system. And they said it's been relatively quiet since then. They have about 265 days of results, and they would like to fill a complete calendar year with 100 days because of the very seasonal character of rainfall in Africa. So there we go. That's where that project is, on a big fat pause. Coming out of MCM. What do we think MCM stands for? Something markers.
Mapping cancer
markers?
Yeah.
Okay. By November 2021, WCG volunteers donated over 800 million work units of research into multiple types of cancer, including lung, ovarian, and sarcoma cancers. 810,000 years of computational research has been donated to mapping cancer markers, with close to 240 years generated every day. That's amazing.
Wow.
World Community Grid volunteers tested 9 trillion candidate lung cancer signatures. That's a lot. There's some nice graphs here, or graphics. Sorry, that's new. That's pretty cool. They really go into depth here, explaining what's going on. Exploring the results further, they found 28 probe sets mapped to 26 genes, are present in all signature sizes. One of these genes, VAMP1, is particularly promising as its protein is involved in synaptic vessels fusion to the presynaptic membrane. Oh, I wish I knew.
That sounds very important.
Yes, but I wish I knew what it meant. Aha! When investigating VAMP1, they found it is significantly linked to the smoking status in lung cancer patients.
Interesting.
Ooh, and here's some pictures that look like guitars. They'll continue with validation. So people are they're still doing stuff with those 810,000 years of computational research donated through MCM. Really cool. It's amazing how much computational research can do for analysis.
Yeah, it's really good to see the MCM project dumping all this information and telling us that the stuff that we're doing is actually making sense to them. It's actually getting them results. So yeah, keep up the good work, everyone.
Yeah. And also coming out of World Community Grid, coming from SCC, Smash Childhood Cancer, they are at the start of a new phase in their quest for curing cancer. Their new target protein is MyoD1, myogenic differentiation 1 protein, and one of his mutations, L122R. The goal is to find compounds that act on the mutant type, but not on the wild type. Interesting. I'm sure they explained that in something I skimmed over. New Smash Childhood Cancer work units have been prepared to help with the search. And volunteers who follow this project will be able to download them once we restart BOINC after the storage failure. We got new SCC work units on deck, ready to go. Woo!
I think the thing with the mutant genes versus the wild genes is them saying they want to find a protein that can target the cancer, which is the mutated gene, versus regular genes that are within the human body. So
I don't know about you. I wear my genes outside my body. Thank you. So that's what I got coming. Oh, I really burned this. Coming out of Smash Childhood Cancer and World Community Grid. Massive thank you once again to World Community Grid for the updates. They are so useful. You got any news?
Not really, just a quick one with Yo-Yo at Home. They're just mentioning that even though M Queens 27 is finished, they found some additional work units that they need to resend. So there's a couple extra work units for M Queens, I think. But that's about it.
Very interesting stuff.
Cool. Let's get right to day 2 of the BOINC workshop. So,
do you mind if I eat a muffin?
Yeah, just make sure you're muted so I don't catch it in the audio.
Okay, I'm gonna eat a muffin.
Yeah. Enjoy your burnt muffin.
Thanks, man.
Yeah. Okay, day 2 for the BOINC workshop. So, yeah, the day 1 and day 2 of the BOINC workshop were 1 week apart. Both of them were at 3 a.m. my time. I made it to the first one because I was presenting, but I wanted to sleep past the second one. So luckily enough, the videos were released, and I went through them, and I can present to you all the information that came out of day 2. If you want to go and see it yourself, you can type in BOINC Workshop on YouTube, and it'll just pop right up. There were some interesting talks, and there were a few that I'm not mentioning here purely because they were more or less like a kind of technical deep dive rather than any news or any new developments that were coming out. So if you want to go and check out more of the technical stuff, there's some extra videos that I'm not going to cover in this little report. And yeah, day 2 was a lot more technical than day 1, I do have to say. There was a lot of people talking about how their server infrastructure is managed for BOINC and so forth. And yeah, it was a lot less on here's what's happening, rather here's what we're doing. So yeah, I'll just get right into it. There are a number of really, really cool projects that presented some really interesting figures. Starting with climateprediction.net. I think you may have heard in the first, the day 1 of the workshop that we did on the BOINC radio 2 weeks ago, I was talking about the fact that we're able to put BOINC on some cars. And that is true. So climateprediction.net was able to compile a special version of BOINC and their weather analysis software to run on a Suzuki embedded system. And this is the little computer chip that's actually in the car that controls various parts of the car. As far as they were talking about, it's an ARM processor, and it has a couple of cores, and I think about 0.5 gig of RAM. So not that many resources to actually use, but it's possible to still use it. So what they did was they stuck this on probably about 10 or so Suzuki cars and had it so that BOINC would run when the car is idle. So when the car is at home, parked in the garage, something like that. And so what they did was they compared it on the ARM CPU to an actual regular desktop computer. And what they found was on the desktop computer, it took 3 minutes to complete the work unit, whereas on the ARM processor, it took 1.5 hours. Now, some would argue that that's a horrible performance drop, but at the same time, we're still taking advantage of this idle processing power. Yes, the desktop computer has more RAM, has more processing power. It doesn't need the emulation that they were talking about to actually get it to run properly and with the correct measurements in the ARM processor. But hey, it's possible. And it's a proof of concept, which shows that it can work in the future. We can actually put BOINC on a Tesla, probably. Yeah, moving on to Einstein at Home. So Einstein at Home was there, and they were giving some news on some of the results that they got. Yeah.
Sorry, swallowing a muffin. That sounded really, really cool. Do you think we'll be able to run BOINC on like my refrigerator?
I know in day 1, David Anderson said that they're probably not looking any further into that particular project of putting it onto little IoT devices like water heaters and stuff like that might be off the cards for a little while, but it's definitely possible. There's people doing proof of concepts for various things. So yeah, anything's possible, but I think cars are probably going to be the next biggest one because mainly they have a lot of computing power, especially the newer ones.
Yeah, I play Call of Duty off my car GPUs. I don't actually do that. I wouldn't know how even if I wanted.
Play Angry Birds on the center console in Tesla or something.
Oh man, that would be really cool though, because everything's gonna be IoT. Like we get to use our PCs for gaming and whatnot, and we don't need to use them for boinking because there's so much processing power in the Internet of Things that there's more than we could ever possibly need. Looking forward to it.
Yeah, interesting to see what comes out of it. But yeah, moving on to Einstein at Home, they had some pretty cool news. So firstly, they went through all the different discoveries that they made over the period of the project. Currently, or rather most recently, they've discovered 39 new gamma ray pulsars. And I didn't catch the metrics on the other things that they're looking for, like neutron stars or supernova events. They're finishing up with the Arecibo data, I think, and they're moving on to other telescopes as well. So there's plenty of more data to be crunched with Einstein at Home if you crunch Einstein at Home like myself. And interestingly enough, there's a Zooniverse project coming out. So the computations at Einstein at Home yielded, I think, a number of billion of results of possible pulsars. But a lot of them were probably from human sources of radiation or radio signals. And they need people to go in and filter out the ones which look like human signals and ones which don't look like human signals so that they can actually nail it down to the actual sources that they want. So it's literally trying to find a couple hundred needles in a 40 billion blade of haystack. So if you're interested in helping out Einstein at Home, there's a Zooniverse project that will be coming out soon for it. And yeah, keep crunching Einstein at Home because they'll have more data. I think one of the telescopes that they're going to be looking at soon is the Meerkat telescope. So yeah, keep crunching. Next, there was a little bit of a talk on containerization and virtualization. So for those of you that don't know what that is, virtualization is like the BOINC VirtualBox. So if you were to get the actual VirtualBox software, which basically runs a different operating system on top of your current operating system. And some projects particularly need it, like, for example, Rosetta at Home or LHC at Home. They particularly need it because some of the computations that they're doing can get really increase the errors in the results cross-platform. So they need to be on a consistent platform so that the results they're getting back are actually the right results. And yeah, that's the problem with virtualization. And the problem with VirtualBox is they have huge virtual disk images. Like if you want to download the Rosetta app for your VirtualBox, you'd basically have to download 7 gigabytes worth of files. So it's insane. And what we want to try and move to is something called containerization instead. So that's where basically there's a software called Docker, which is kind of like a VirtualBox, but not like a VirtualBox. Instead, what it does is it simulates the features and the components of an operating system, but not the entire operating system itself. So for example, if you were to run a Docker container running, I don't know, Python on Ubuntu Linux, you won't be able to like go in and like click on things and see like the files in Ubuntu, but rather you will be able to go into it in like a terminal and have the same sort of environment that you get with Ubuntu, but it's not actually really truly Ubuntu in the background. It's just emulating the environment that it's in. And the advantage of that is it's highly reproducible. So you can send it on one machine, you can send it on another machine really simply. It doesn't cost as much of the data as you get with VirtualBox. And it's basically a new modern standard now. So it's got a lot of features, and people within the BOINC community, especially project admins, are going to be looking into this to solve some of the issues that they're getting with virtualization. All right, moving on to LHC at Home. They had some really interesting things. So LHC at Home have been developing something new. Now, before I get onto what's new, let's take a look at what they already have. So for those of you crunching LHC, you'd know of the 6-track project and all the other projects that they have around it, like Atlas and CMS, I think it is. yeah, the problem with all this software is that it's really old. Like they mentioned that 6-track is programmed in Fortran. And for those of you that don't know what Fortran is, it's an ancient relic of programming languages where only a few select people in the world can actually program it, because it was made back in the days of when banking was just getting off the paper books and onto computers. And Fortran was the language of choice. And yeah, basically new modern languages have far surpassed it. And only a few of those people who are back in the banking era when people were using it actually know how to actually program it. So they're finding it hard to maintain 6-track. So what they did is they basically said, you know what, let's rewrite this so that we can get it into something that's more modular and something we can take into the future. So they're making Xtrack. Xtrack is written in Python and manages a whole bunch of modules. So you're probably thinking, well, hold on, why are we writing something in Python when it's used for computational stuff? Because Python's really slow, right? Fair enough. But what they're actually using the Python for is to manage compiled binaries along with other software as well. So the Python stuff is not necessarily computational. And also, if they do have anything written in Python, they will be pre-compiling it first. So yeah, the stuff that they're using in Python is not necessarily going to be for computational stuff, but rather managing the computational stuff. They've got a really whole big like deep dive onto it on the actual BOINC Workshop Day 2 video, if you want to go and check it out. And basically, to sum it all up, Xtrack can do what 5 different code bases that they already have can do. So it combines the functionality of everything they got there and streamlines their maintenance process into the future when it comes to creating new apps and creating work units. So if you want more details on that, go and check it out. And yeah, I'm really keen to see what comes out of it. Now, number fields at home. NFS was on there, and I quite enjoyed their talk because they went through a lot of the history of the project and the numbers and what they do and how they do it. And because I totally didn't know that number fields at home is actually a project that's continuously testing just prime factorization problems. Like it's just to continually push and make sure that our cryptographic algorithms are like secure. And it's just continuously working on one single computational thing, which is prime factorization. No sub-projects. I mean, they technically did have a couple sub-projects in the past. But yeah, the primary thing that they focus on is that prime factorization. So interestingly enough, NFS at home, although they're using BOINC, they're also using a supercomputer. Why, you might ask? They have a workflow. Their workflow starts with choosing some numbers to send into the input for the BOINC projects. For the BOINC work units. Work units get sent out, crunched, factors and everything come back. And then that gets all dumped into a big, massive file and database. Then what they do is they take that file and then they send it to a supercomputer to go and sift through it for the ones that they actually want. Now, you're probably wondering, why don't they just send this on like BOINC and do that exact process all over BOINC again? I can only assume that it's something that they can't do in parallel. So they have to use a supercomputer. At one point, there were so many BOINC computations that the supercomputer couldn't keep up with the actual work that was being pumped out of the BOINC project. And that was soon solved by, I forget what the project admin's name was. I apologize. But what they did was they basically turned the CPU supercomputer app into a GPU supercomputer app. And instead of taking a couple days to process all the results from BOINC, it took probably about 15 minutes. So yeah, pretty much that's the results of the supercomputing that NFS at home does. And if you're curious about what they actually use, they use something called Access from the National Science Foundation. And they get free supercomputing power. So if anyone wants to go and search it up, feel free. And yeah, they're getting a lot of traffic going through the project, and it seems to be a pretty healthy project. So yeah, good luck to everyone out there doing number fields at home, and keep crunching, because they said at the BOINC workshop that they're really enjoying the results. So keep it up. There was some talk on BOINC Central. So I think we talked about this in day one, so I don't think I'll spend too much time on it. Vitaly was on there talking about BOINC Central and how they use Autodoc Vina to actually just run computation straight from a protein analysis application. So if you're interested in that, and how scientists don't even need to create a new BOINC project to run, excuse me, to run protein folding, then go definitely check it out. But probably the thing that everyone's probably wondering about, because Jeringa mentioned it earlier, is machine learning. So a lot of us are really keen on how machine learning is going to come into the BOINC ecosystem. And there was a little bit of talk about it on day 2. Now, we already have some frameworks that do decentralized machine learning. For example, you might have heard of Petals and Swarm. And there was a talk on day 2 that actually mentioned how we can get Petals and Swarm onto the BOINC network. There was talk about basically just rerouting the network traffic. There was also talk about like loading the apps onto the actual people's computers, and then tracking it and running it, and calculating the credits based off it. For those of you that don't know what Petals and Swarm is, Petals is a really, 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 really big chat model. I think, yeah, it's a chat model. And it's distributed over a whole bunch of different computers. So for example, if I'm running Petals, I might be running probably like probably a quarter of the model. And for the record, the model I think is about 3 billion parameters. So I'll probably have less than about 1 billion parameters being computed on my computer and then sent back out to whoever requested those parameters be computed. And basically, yeah, everyone around the world will have like a little chunk of this language model, and it'll also be replicated as well. And yeah, like when someone says, okay, send this prompt into the language model and then get its output, what it'll do is it'll say, okay, calculate the first quarter on that computer, then calculate the second quarter on that computer, and then calculate the third quarter on that computer, and the last quarter on that other computer, and then send the results back to the person who requested it. This can be done on BOINC too. All we got to do is basically load Petals onto participants' computers and basically just have it running. There was more technical talk if you want to see the actual technical details on how it'll be possibly executed in a BOINC project. But that's that. As far as Swarm goes, Swarm is distributed deep learning, and it has kind of the same principle. So if a scientist has a deep learning workflow, literally it is so generalized that no matter, pretty much almost no matter what the scientist or person who wants to do the deep learning wants to do, they can do it on Swarm. So if you want to train a convolutional neural network on detecting whether a traffic light's red or green, go for it. Like, it's possible. If you want to detect whether Jeringo's picture on the live stream is a cat or a dog, you can do that too. All with Swarm. And same principle applies with Swarm and Petals. If it were to come on BOINC, basically we'd need to load the application onto the participants' computers and then just set it and run it. There needs to be a little bit of a wrapper around the actual software to actually allow it to interact with the BOINC server. But I think it will open up access to these projects and distributed projects a lot wider, because people no longer have to be a bit more technical about how they actually run these things and need a bit more technical information. Rather, they could just sign up to the BOINC project, have it load on their computer, and they can just run it. So I think the potential with these projects is huge. We just need someone to hop on board and actually make a BOINC project for it. And as far as that goes, that's pretty much all of BOINC Workshop Day 2. Do you have any other things you wanted to chat about, Jeringa?
If we're just chatting, I'll chat about books, reading good books.
I actually haven't read that many books. I need to start getting back into reading. I kind of dropped off reading.
I appreciate you. No, I've got nothing else to talk about. That was an awesome summary. I think the AI projects will be really cool if we can get some of them to hop onto BOINC.
Oh, absolutely, yeah. They're actually, not only will I think it'll be just cool that the AI projects come on, but it'll probably attract a whole lot of people to BOINC if there's like these massive AI projects that you can crunch on. So
Yeah.
I really think there's a lot of potential here. Someone just needs to hop on it.
Yep. All right. If that's the day, that's the day. We'll call it a day and see you in 2 weeks.
Yep. See you in 2 weeks.
Bye, everybody.